Okay, so we're going to jump into a geometry question here. It starts off relatively straightforward, but then gets a little bit complicated. It's a mixture of angle rules and trigonometry, both right angle and non-right angle. So the first thing we're going to look at is we have to work out what angle ABC is. So ABC is obviously this angle here. So we're trying to work out that angle there. Now the key bit of information that we're told is that AOC is diameter. So that should send off alarm bells already, meaning that this line here is a diameter. And the alarm bell should tell us that we know that there's a rule saying that any angle in a semicircle, which because that's a diameter, that would be a semicircle. Any point or vertex that touches the circumference in a semicircle is 90 degrees. So straight away, we should be able to just write that that's 90 degrees, and if we're asked for a reason, it's angles in a semicircle. Okay, so look that rule up if you're not familiar with it. It's basically a variation of another rule that says angles at the circumference are half the angle at the center. And that makes sense that if this was 180 at the center, it means that half of that would be 90 at the circumference. So that's another way you could answer it if you didn't remember the semicircle rule. All right. Between questions, I'm going to tidy this up because obviously you're going to draw on the diagram and it makes it a bit clear. But all the key bits of information I'm going to leave in. The other problem with this question is that answers flow on to the other questions. So if you do make mistakes, it carries over. So it's really important that while it's not to scale, your answers should make sense in terms of what the diagram looks like. But you're also only penalised once for making a mistake, and if you carry over that mistake, it should you shouldn't be penalised again. So the second part is then asking us calculate the angle at ACB and show that it rounds to 35 degrees to the nearest degree, which is nice that we can work out our answer and see if we've got it right or not. So we need to use the fact that that's, first identify the angle, so ACB, which we are looking at this angle here. And because we worked out on the last one that's 90 degrees, we're going to show our 90 degree trigonometry to be able to answer this question. It's always a good idea to draw a diagram when you have so that you're a bit clearer rather than trying to use the original diagram because it can get confusing. So the information we're told is that this is 7 centimeters, this side is 10 centimeters. Sorry, I should put the labels in, A, B, C, and we are trying to work out the angle there. So using our trigonometry, we know that that's the hypotenuse, that's the opposite, that's the adjacent. So we're not using the hypotenuse, so we're using tan. So tan theta is equal to O divided by A. And then substitute in the values. So tan theta is equal to the opposite, which is 7 divided by 10, meaning that theta must be equal to the inverse of tan. Remember, because we're finding an angle of 0.7. Okay, then we can get our calculator. Make sure we cleared it, make sure we've got it in degrees. Then we just need to use inverse tan. Oh, I pressed that twice, didn't I? So inverse tan, 0.7, close bracket, equals 30.4.999, which rounds to 35. So it would be equal to 34.999 Make sure we make that point really clear. Okay, to 4SF, which is equal to 35 degrees 0 dp, or to the nearest degree. So now we can tidy that up again, that we've got our added bit of information here, that we can recognize that this angle here is 35 degrees, now that we've rounded it. And obviously if you get that wrong, you still know what that answer should be, so you can use it in the next part. So again, part 3 tells us that ABD, which is this angle here, ADB, here is the same, so we can write that in, that's 35 degrees. And the reason why is pretty simple. We have the rule that angles that share the same arc or the same part, you can see that they both of these angles start and finish at points AB, so they share the same arc, so they have they must be the same. So I can write as the angles share the same arc. Now, I don't have the marking schedule of this, so I don't know. It might be possible that the question's actually requiring us to prove that these angles are similar triangles. I don't think so, because it asks about us later on, and the way to do that would be to confirm that all those angles are the same, so they must be similar triangles. But because it's a 1 mark question, I think that's a good enough answer. But it wouldn't help to say so they are similar triangles. Just to cover yourself as well. So I'll just pause this to tidy it up before moving on to the next question. Okay, so part